So EME stands for Earth, Moon, Earth. It means bouncing your signals off the moon and bringing them back to work somebody else at some other location, perhaps a different continent even. It works pretty well at VHF frequencies and higher, so it's primarily a game for the 6-meter band and shorter wavelengths, higher frequencies, all the way up into the gigahertz range. One of the biggest challenges in ham radio since the, shortly after the Second World War has been to bounce our signals off the moon and bring them back to Earth in a way that we can communicate with somebody else who also has the moon above the horizon so they can see it. It's not so much that you can't work people at a distance other ways, it's that this is sort of hard, and therefore if you can do it, you can brag about it. It's a lot of fun. The challenges are primarily just that the total distance of 500,000 miles is so large that the so-called path loss, the number of decibels of attenuation of the signal for the round trip, is huge, well above 200 dB. Depends on the frequency and it depends on the details of how you're defining it. But it turns out that you can do EME with antennas that are big by ham standards, but not impossible. And as you go higher in frequency, particularly these days when technology is developing so that we can develop significant power at, say, the 23 centimeter band or even higher frequencies than that, it turns out you can do it with antennas the size of a 3-meter dish, even smaller in some cases. So the round trip is, it's 250,000 miles to the Earth, to the moon more or less, and therefore a 500,000 mile round trip, about 2.5 seconds there and back. So there's significant delays. If you're working CW, you stand by and you wait a few seconds before you expect to hear the other signal. Same thing if you're working digital modes. There's a very significant delay.
Well, we have 2 stations here at W2ZQ. One is the 3-meter dish, the one we started installing in 2018. And that one's equipped for 23 centimeters or 1296 megahertz. The new dish that we got the ARDC grant for is 4.57 meters, and that one will also be motorized, and it can track the sun or track the moon or anything else in the sky that we want to point at it. I've been a member of this club since, since I was 14 years old or 15 years old, and back in 2018, I had an extra dish at my house, and my wife said, "Why don't you get rid of that?" Okay. So I brought it over to the club, and I met with some of the leadership here, and I said, "Would you like a dish to build a Moonbounce station?" And they said, "Sure, you can build a Moonbounce station here." So in the summer of 2018, I started building, and Saied was part of the crew, and we dug a hole and put a pedestal in, and slowly built a station, and then pandemic happened, so that kind of slowed things down for a while. But as soon as the pandemic was over, we re-engaged, even more people got involved, and we started contesting actually at some point. So.
We had contests for a couple of years, and people with bigger antennas and more power were coming out ahead of us, so we kind of sat here and brainstormed and said, what we need is a bigger antenna and more power. We wanted a bigger antenna, so what we did is I think one of the club members suggested maybe we should apply to an ARDC for a grant. So we kind of came up with a list of things we wanted to do. Paul went through the exercise of estimating what it would cost us to do the different parts of the project. And I looked at other proposals, see how people have done. And Joe had a whole bunch of ideas about what are some of the other things we could do in radio astronomy and get college students involved. So we put all that stuff together, wrote the document. So we submitted it, and sometime later, we got the grant and then started on the project.
And it's probably worth mentioning that we had access to the dish already.
Yeah, this is a big dish. It's 4.57 meters, so my wife would have been very upset if this one came home, so the station is a good place for it.
These are mainly just ideas at this point, but with a dish of that size, we could easily do some radio astronomy. It's easy to detect signals from the sun. In fact, we use the sun regularly for pointing tests and for sensitivity tests of the existing 23 centimeter station. But with this new dish, we will be able to detect other sources as well. We might even use both dishes together sometimes as a so-called interferometer, interfering the signals from the two dishes to make maps of the sky to higher resolution. That's a fairly big project and may or may not get off the ground quickly. But if we make the setup accessible to students, perhaps even by remote access with some kind of advanced notification, we could allow students at a nearby, say at Mercer County College, to do some kinds of astronomical experiments using this antenna.
Large motorized dishes are rare, so it's a great asset.
It's wonderful to do it in a group because a single station operator to put together that kind of capability is an immense effort. And I felt, I mean, I had my own station for a while on 2 meters doing EME. That was a lot of fun, but when I started reaching an age at which I needed to downsize, it was clear that I wasn't going to do that at home anymore. And it was great to join this club and to enjoy not only the Moonbounce capabilities, but to improve them and to enjoy all the other things that this club does so well. It's a remarkable club, actually, because of all the range of different activities, capabilities, and skills that we have together among the membership.